Aldol condensation. Reagents and mechanism. Aldehydes having alpha hydrogen reacting to form β-hydroxyaldehyde, also known as aldol. Aldol condensation, they take place in basic medium and acidic medium. Dilute NaOH acting as a base, helping in the formation of a β-hydroxyaldehyde, aldol. In acid catalyzed aldol condensation, acid helps in the formation of β-hydroxyaldehyde via enol. It also helps thereafter in the formation of alpha-beta unsaturated aldehyde or ketone. Crossed aldol condensation. In this condensation takes place when one of the aldehyde doesn't have alpha hydrogen and the other one has alpha hydrogen. Base catalyzed aldol condensation. Base abstracts proton from an aldehyde. It forms carbanion. And then helps in the formation of a enolate. The carbanion attacks another molecule. This O- now attacks proton of water, making it as hydroxyl group. This then reacts with an acid, making it as hydroxonium ion OH2 plus, and this then helps in liberation of water molecule, and then we have a alpha beta unsaturated aldehyde. Another example of base catalyzed aldol condensation, acetophenone in presence of base. Carbanion formation taking place at alpha carbon, one of the alpha hydrogen getting abstracted by the base. This carbanion now attacks C double bond O, helps in the formation of an hydroxyl group at the beta position. Eventually we get alpha beta unsaturated aldehyde. Acid catalyzed aldol condensation. In this, acid reacts with aldehyde and alpha beta unsaturated aldehyde formation takes place. Mechanism of acid catalyzed aldol condensation. Proton from HCl goes and gets attached over C double bond O. Now oxygen develops a positive charge, which then helps in the formation of an enol. This enol then attacks another molecule C double bond O, eventually leading to the formation of carbon-carbon bond. First the beta-hydroxyaldehyde formation takes place, and later alpha-beta unsaturated aldehyde formation takes place. Cross-aldol reaction. One of the molecule is having alpha hydrogen, another one doesn't have alpha hydrogen. So that way the beta-hydroxyaldehyde formation becomes easier and not many cross products are also formed. Why it is the most important reaction? Synthesis of carbon-carbon bond taking place, joining of two carbon atoms. One of the carbon becomes negatively charged, another one positively charged. Most of the organic compounds have carbon in the positive form. Therefore, challenge is to generate negatively charged carbon atoms to allow two carbon to get attached. Aldol condensation reaction was introduced by Charles Woods, who first prepared beta-hydroxyaldehyde from acetaldehyde in 1872. Questions. Why does OH minus act here as a base? Does it act here as a base or a nucleophile? If hydroxyl acts as a base, it should then react with an acid. Does acetaldehyde looks like an acid? Okay, if acetaldehyde here is acting as an acid, it should then donate a proton, which H of CH3CHO can easily come out of as a proton. Why only alpha hydrogen comes out as proton? What happens to carbon after alpha hydrogen comes out? Does negative charge generated on carbon remains stable? What factors make negative charge on carbon more stable? Why carbanion forms double bond and allows C double bond O to become CO minus? Why not O minus gets attached to C plus of C double bond O? Why negative charge on O minus comes back to C minus, eventually making it as a nucleophile? Why C minus is attracted to C plus?